Hello and welcome back to Lexx Education, the smash hit comedy podcast, science podcast, where my little brother Ron,
Hello, I'm Ron.
that's Ron, he tries to teach me. Hello, I'm Laura. Science. It's episode 5, chemistry 2. Welcome back. How are you doing, Ron?
It's good. It's our first early morning record because you're about to get on a train.
I'm coming to see you today.
Hooray!
Very exciting. Now, before we start the episode, we would like to thank Podspike. They are friendly, tame podcast marketing people. We found them in the wild. They found us in the wild. They probably found us in the wild, didn't they?
They did, yeah.
Yeah, they very much found us in the wild. And they said, hello, would you like to start your podcast alongside somebody that knows what they're doing? And we said, oh yes, thank you very much, please, that would be kind. And so they showed us how to launch a podcast, and it's worked, hasn't it, Ron? Because these people are listening right now.
I think it's gone swimmingly.
Yeah, we hit 1,000 downloads this week, which we think for week 2 is pretty spicy. That's nice, isn't it, Ron?
It is nice. Yeah, we got a badge.
We did get a badge. Can you stop tapping your desk, please? You're very unprofessional. You know all about science, but not about broadcasting. So, yes, chemistry. Thank you, Podspike, and chemistry. We're back with you today. Now,
Thank you, chemistry.
I would never thank chemistry. Don't be ridiculous. I hate chemistry. And thank you to people like Greg, Helen, Colin, Matthew, and Kay for your sort of quote tweets of episodes. That really helps. As well as the interacting and the chatting that we've been doing with all of you guys underneath. It's lovely. Thank you very much. And Becky Lulu, thank you for your Instagram post. We really appreciate it. Ron, we've had a new Apple review.
Yes, from Riddled with Gin. Someone I think we could get along with.
I do like a bit of gin, although I had some port this weekend, just a sniff, and it was very lovely. Riddled with Gin says, all the joys of GCSE science without the strange teachers, which I think's nice for you, Ron, because that means you're not strange.
Yeah, I'd go with that. I don't know what the joys of GCSE science are, but
No.
we're producing them.
Yeah, there isn't a joy of GCSE science as far as I'm concerned, but there is joy in podcasting. Now, last week we were talking about chromosomes, were we?
Yeah.
Probably. And and we asked if any of you guys knew why X and Y chromosomes, why don't we use the Z or whatever? Now, Mystic says that there are W and Z ones in beetles and animals.
No, they said that there are W and Z ones in beetles and birds, I believe.
Yeah, but birds are animals.
Yes,
so.
but not all animals are birds.
But all birds are animals. I love birds. I've got a bird feeder, and I'm training Mackie to shout at the pigeons, but not at the sparrows. Anyway, so that's one thing. Maybe there are W and Z, and then Daniel suggests that the chromosomes look like an X and a Y.
So they come in pairs, joined in the middle.
God, everything's in fucking pairs, isn't it?
They come in pairs, joined in the middle. So the X ones, which are the long ones, they're kind of joined in the middle. So when you get the two of them, they look kind of like an X. And
so
then
they,
the Y
they
one...
like join halfway and like flex their crotches into each other.
Yeah, and then the Y one is much shorter, so it would kind of look like a Y, but with kind of a vestigial tail. But I thought that too when I was having to think about this, and I texted a friend of the podcast, Noah, about this because he's a biologist, and he was just like, yeah, of course, that's why it is. But I couldn't find any evidence for that being the etymology of X and Y.
Okay. Well, there we have it. Even more science, which is what we all came here for. So we're going to jump back into chemistry 2 with a big look on some atoms.
I'm excited to get back into it.
You just love science so much, you geek.
I do. Not chemistry, though.
No, physics is the worst one. I didn't mind chemistry, those plum puddings and the little sad reggae boys.
Now that's how I can tell, or the listener can probably tell that it has been a long time since we recorded those episodes, because you really did fucking mind chemistry.
Oh, okay. Well, it's mellowed a bit in my memory of it. Maybe physics was just so shit going back to it that
I
now
think
I'm
what
like,
happened
ugh.
was you just did quite well on the quiz.
Could be that. I do like to be the winner, kid.
Yeah, physics is worse though.
Okay, so just give me a quick rundown on what we did last time. We did electrons, they go in rings. That's how things go on the periodic table.
We did the makeup of the nucleus.
And it's
We
a
did
sort of
atoms,
subtle look
basically.
with contouring and a little bit of shading across the brow line.
I don't understand what you're saying to me.
You said it was the makeup of the something or other. I didn't listen to the rest of it. I thought of...
Oh, I got that you were talking about makeup. I thought nucleus was some makeup term that I had
Oh,
heard.
no. The makeup of the nucleus must be what you said, but I didn't even hear the word nucleus because I started to go, I thought of something.
Okay. Yes, and.
The nucleus is the brain. It's inside a membrane.
Not in atoms.
What? I thought it was.
In cells. In cells, it's in a membrane, and not in atoms.
Why don't they call them something different?
Because it probably comes from Greek or Latin or something.
Oh, how the fuck are you supposed to remember that? So they both have nucleuses, but they're different things.
Yes.
What's an atom's nucleus then?
It's the bit with all of the Bob Marley.
Don't rub
and
your
the,
eyes already. It makes me sad when you rub your eyes.
It's the bit with the Bob Marley and the sound engineers that keeps all those
Oh,
sad
yeah,
boys
that was
in
the
line.
sound desk. That was the little
Yeah.
mixer. Okay. And then the party's going on around them. That's where they store the neutrons.
Yes.
And that's
yes.
how
Well,
determines how heavy the cell is, atom is.
yes. So, I mean, great segue. So, basically, for most of today, what we're going to be doing is just getting a little bit smaller.
Hello.
So, learning, well, like smaller than atoms, we're going to be learning more about the bits that make them up. Okay?
Okay. The organelles.
That was a joke, yeah?
Like the atom organelles. I'm assuming from your pausing that cell atoms do not have organelles. But, like the organelles of the atom is what I mean. Clever girl.
Oh, I thought you were joking. I might have broken up there for a bit. You definitely froze and were giving me a very derisive look. Okay, so do you remember which particles are positively charged and which ones were negatively charged?
Now, like, the Englishy part of my brain is telling me that protons would be positively charged because they're pro. So I'm going to say protons.
Correct.
Yes!
And the electrons are negatively charged.
Yes.
Neutrons are neutral.
That makes sense. Well done, language.
Hooray! So what the concept that they want us to learn about first is the idea of relative charge.
Okay. That's where you ask your aunt and uncle for money before they come and stay with you.
I was going to say when you run at a line of your cousins very fast. No, so relative charge
Which cousins are you
is...
picturing when you say that?
Oh, the weird ones.
When is he? Oh, that's
Yeah, so the idea of relative charge is basically a simplified way to look at the charge of not only these small particles, but then these small particles determine the charge of molecules and and ions and larger things as well. So basically what we say is protons have a charge of +1 and electrons have a charge of -1.
They cancel
Okay.
each other out.
Exactly, yes. So it basically means that because whenever an ion or a molecule is charged, it is either...
Hang
it's
on, what's
basically,
an ion? What's a molecule?
We'll get to those in a second.
Okay.
It just means that when those are charged, they're either lacking electrons or they have too many. So it's always going to be increments of this relative charge of plus or minus a number.
Okay.
Sure, mate. I mean, everything you just said there was just like, so it'll be a number, okay? And then you paused and looked at me, and I realised I was supposed to be processing that information. But I was waiting for it to get to a bit that meant something to me. It didn't happen.
Well, it's just because I don't know. I can't actually remember the unit for charge, but like a proton's charge would be teeny, tiny, because they're so small, right? So what you could do is you could say, oh, this ion has a charge of 0.00001, whatever's. But that would be a bit tedious and hard to work with. So we just say that is +1. It's relative to the atom. And then that just simplifies it when we talk about it.
Charged with what, babe? What are you talking about?
Like,
What's it
like
charged with? Like just atom juice? What is it?
magnets, basically.
Oh! Because I was just thinking there, just give it whatever number you fucking want, science. Who cares? You're the only ones talking about it. But it's magnetic in the same way that other magnets are magnetic.
Yeah, opposites attract.
I don't know what that's got to do with anything, but like, so you could
So
you could measure the charge of a proton against like a fridge magnet.
Yes.
That's why you're saying it's simplified to go to 1.
Yeah.
Okay.
And then, so opposites attract. So you've got all the negative electrons floating around the outside,
So
attracted in.
everything's metal.
No. Everything is electromagnetic energy. No, that's not true. Cut that.
I'm not going to. I'm going to leave it in with a big whack whack oops noise, and then a big flashing light will start wherever someone's listening to the podcast, and in fireworks it'll say Ron is dumb, and a little dancing version of me will be dancing around. Doo-doo-doo-doo-doo-doo. Ron is so stupid. What an idiot. He thinks the whole world is full of, what was it, electromagnetic energy. What an idiot.
Electromagnetic energy.
He is an idiot.
Right. So let's move on from relative charge because I feel like we're circling a very depressing drain.
We just call everything 1 to make it easier. I agree. Well done, science.
Yeah. So it just means, the example that I thought was the easiest to look at is table salt, which we've talked about before, sodium chloride.
I remember
right?
this bad boy, NaCl.
The sodium gives
Na.
its electron, gives its electron to the chlorine.
Yeah.
So what charge will the sodium ion have now?
Positive.
Yes, meaning that and what charge? Like what number charge? How much charge?
6? I don't know, how many little plums
Fucking
has it got?
1. It's 1.
Why is it 1? Surely it should be
Because it's
-1.
given-
It gave something away.
Yes, but it gave a negative thing away.
Well, so it was 2 before and now it's 1.
No, it was 0 before, and now it's 1.
Alright. Okay, cool. What?
Like, it's given away a negative charge.
Yeah.
So
you can only
now,
ever really be -1, 0, or +1.
Well, using your periodic table, give me the next element along in the row from sodium.
Now I've got to find sodium. Where's he hiding? Oh, he's over here in group 1.
What's the group 2 element in that row?
Magnesium.
So magnesium, remember, because it's only got 2 electrons in its outermost shell, it's quite easy for it to shed those 2.
Yeah, fuck off.
So magnesium could shed both those electrons, which would leave it with a charge of...
Neutral again, 0.
No, it's shed 2 electrons.
But if everybody's in pairs, they're happy, aren't they?
Yes, but they're both negative. All electrons are negative.
So who's got protons?
The nucleus of the atom.
Okay. Oh dear. So he's -2 then.
+2.
Plus.
Because it's given away 2 minus things.
Wait, so where was the neutrons? They're in the nucleus as well as the protons.
The neutrons are in the nucleus, yes.
Oh, it's crowded in there then, isn't it?
'Tis indeed.
I think I'd rather be an electron. A bit freewheeling.
Yeah, you get around more when you're an electron.
Yeah.
Leading back to your question earlier, and I'm sure you're going to ask about a few more things.
It doesn't sound so miserable that I'm here.
No, it's just I was really worried that I hadn't done enough research for this episode. We're already right in the weeds, and also we're covering a lot of what we've covered in previous episodes.
Nah, we have not talked about any of these sums.
We absolutely we did the whole of the last episode on the structure of the atom.
Yeah, and I've remembered some of it. Plum pudding.
Plum bloody pudding. Right. So an atom is when there is an equal number of protons and electrons, therefore not charged. Okay?
Hang on. Atom equals protons equaling electrons. Atoms are neutral. The neutrons don't come into it.
No, not quite. So that's an atom when the electrons and the protons are in balance. If the number of protons changes, that changes the element.
Yeah.
So another proton in a sodium nucleus makes it a magnesium.
Changing the protons changes the element.
Yep, and the proton number, you'll see the proton number on your periodic table. It's the one that...
This is magic, isn't it? Just changing into a different thing. Boop, boop, boop. I'm not chlorine anymore. I'm gold. Boop, boop, boop.
That's alchemy.
Yeah, just by changing the So alchemy is possible?
I mean, I would say it probably is, but I just don't think we have any idea of how to do it. It would take an intense amount of energy.
Okay, so changing the protons changes the element, but it doesn't change the charge.
Well, it would. Yeah.
So some things are just, they all start with different charges.
No, so it's not often that protons leave or join a nucleus. What I more mean by that is just the number of protons defines the element.
I'm confused now. So when sodium and chlorine get together,
yeah,
why doesn't that just change chlorine into the thing in the next column?
Because they are exchanging electrons, not protons.
Electrons is the thing, Ron. Changing the protons changes the element, you clever boy.
Yes.
Okay.
So protons, the number of protons defines the element. A change in the number of electrons, that makes an ion.
Changing the electrons, and you have to plug an ion in electrons.
I didn't understand that at all.
If you're using an ion, you've got to plug it in to use some electricity.
Ion.
So changing the electrons makes it an ion.
God, that was one of the most tedious ones I've seen come up. Right. So when the sodium atom sheds its electron to the chlorine atom, they both become ions because they are now charged and they have an uneven number of protons and electrons.
Okay. Does shedding a proton make a charge.
It would, but it very rarely happens.
Okay, let's not bother learning about that then.
Yeah, like that's we
Sack
might
that
come
off.
across. We might come across that. I believe that only really ever happens during radioactive decay.
Radioactive.
well,
Radioactive.
Hey, we're gonna get bloody sued. Stop that.
Sorry.
But we'll come across that. And then we talked about this. I think in the last atoms episode we did. A different number of neutrons makes a different isotope.
Isotope sounds like a made-up word, doesn't it? Changing
Sounds like a baseball team.
the neutrons makes an isotope.
Yeah, a different number of neutrons
And
is a different
that's
isotope.
the weight of the neutrons are the
Yeah.
big boys.
So you could have a an oxygen atom. It's got 8 protons.
Mm-hmm.
One of them might have 8 neutrons. Another one might have 9 neutrons. They are different isotopes to each other, but they are both oxygen because they both have 8 protons.
Would they feel different to breathe?
No.
Okay. So
In
I don't
fact,
think
you are-
isotopes matter then, do they? Let's
You
not
are
bother with those
breathing-
either.
You are breathing hundreds of different isotopes all at once, all at the same time.
Ron, what is the point of all of this?
Well, we'll learn some more.
Oh no. I hate it when we've done a bit and I go, great, I've got that in my head. And then it turns out that was the 2 lines as the introduction to what we're about to go on and do.
No, it's more just kind of today is a lot of just learning stats and facts about atoms.
Okay. Ooh, we should make top trumps with different atoms on them, Ron. Then we could play top trumps.
Yes.
Like I'd say to you, hang on, let me get my board and have a look. I'd say to you, oh, I'm molybdenum, and I've got 42 electrons.
And I'd say I'm cadmium and I've got 26 electrons.
Oh, well, I've won then, haven't I? Give me your cadmium. Good content. Do-do-do!
Okay, so
molybdenum is a transition metal. So don't tell J.K. Rowling about that one, because woo, she will be kicking off. Oh, I've just
Right,
realised
okay.
I'm using my notebook back to front. Ah, I'm so stupid. No, I'm not. I just had it upside down. Don't worry, I found my page.
yes, that means you're not.
I'm not stupid after all. Well done, me. I did some gardening today and I thought about biology.
Well, what did you think about?
I thought about how
I'm touching biology.
I thought about how the sun makes me feel nice and it makes plants feel nice. And I planted a flower that doesn't really like to be in full sun. And I thought maybe that's got less maximatosis things to make ATP, so it doesn't want as much stuff to convert into energy.
It's got less myxomatosis, a disease.
I know that that's not the right word, but I can't remember what the right word was. Hang on, where's my...
Well, we'll find out in episode 7.
Not microscopy. Mitochondria make
Yes.
the ATP. God, what the hell is that drawing? Yes, a sperm that looks like a key is kissing a frog with big lips. Ooh. I was wondering if a plant that likes to be in the shade, maybe they have less mitochondria. Can't cope with as much conversion.
It's probably they might do but the causation is probably the other way around. They've probably got less because they like to be in the sun, not they like to be in the sun because they've got less.
Well, how do they just like something? They're plants.
Let's just
Let's save this confusion.
Yeah,
for another
let's
day.
not get into
Ugh.
selective pressures and natural selection now. We need to talk about the size of atoms.
Very small. Done. Next thing.
Teeny. Would you like to hazard a guess as to how small in meters?
So small that it's fucking garbage that we're talking about them. Because if we just left them alone, there'd be no nuclear war, no nuclear reactors. We could just carry on with our lives not caring.
Would you like to hazard a guess as to how small? In meters.
In meters? That's too big to measure something like an atom.
All right, in nanometers then.
I don't know what that is. What's that?
That's
like a
why I
grandparent of a
said
meter?
fucking meters.
Hello, I'm Nanometer. I hope that's a character in some children's science one day. I'm Nanometer. Let me tell you about how small things are in my day.
Be the change, Laura.
Nano, in meters. So a meter is big. Like, what's a meter? About the size of a wheelbarrow. And then... and then an atom.
Relatable.
An atom is way smaller. So let's say a millimeter is... I don't know. Hang on. How big was a cell? And then... Is a cell bigger than an atom? I don't think cells and atoms exist in the same world. They, I'm going to say... I think it's about 20 atoms to the millimeter.
No. So, an atom is about 0.1 nanometers across. That's including all of the electrons whizzing around the nucleus. That is 0.000000001.
How many noughts?
9, I believe.
Whoa. 0.000000001 meters. Is that?
Yes. Yeah.
How much is that in millimeters? Because I can't think about that.
In millimeters, then, that would be 0.601.
3, 4, 5, 6, 1 millimeter. Oh, they're even smaller than cells.
Was that a joke?
No, because I don't understand. Are cells made of atoms?
Yes!
Why are you saying it like that?
Because what the fuck else are they going to be made out of?
I don't know. Cell parts. Organelles. Those little men that stood together and made a membrane.
Okay, right. But let's track this back. So if...
Are all of those people made of atoms?
Everything you've ever seen or touched, heard or smelt is made out of atoms.
So is air an atom?
It's more than one.
And so is a lysosome.
Yep. Name another thing. I'll tell you if it's atoms.
Don't be a prick. Oh, God. Well, I feel like then who cares? That is so small, Ron.
Yeah,
How did they split that then? How do you break up one of those?
Well, you fire...
That is so
You
much
don't
glass
see
in a
it. You
microwave.
fire another one of those at it.
That's cruel.
Yeah. Here's a fun thing though. The nucleus
You're
of the
lying.
atom is 1/10,000th of the atom's radius. That's how big it is. So 9,999 of it is empty space.
What, with a wall around the empty space?
No?
So, why isn't the atom just small then?
Because of the electrons whizzing around it.
Oh, they just whiz. They're not on string. I thought they'd be on string.
No, they whiz, held in by the magnetic charge.
Clever.
Mm.
Oh, I think there might be a god, you know. This all just sounds too stupid to have happened on its own.
Do you remember the last chemistry episode we were talking about?
I thought I did, but I thought I'd had a good time. And now I'm sitting here. I just want to cry and go downstairs. And I guess I didn't have a good time.
But do you remember old Ernie Rutherford?
No.
The guy that was
Is he a
firing...
farmer?
No.
Who was
he
that farmer that made peas that you always used to tell me about?
Mendel. He wasn't a farmer, he was a monk.
Uh,
Yeah, do you remember Rutherford? He was the guy that was shooting particles at some gold foil. And some of them went through, but crucially some of them bounced back.
oh, yeah. That one. That took us a long time to understand.
Yeah, the bollards instead of the wall. So this is why. It's because the nucleus of the atom is such a small point inside the greater space of the atom.
So everything's just floating about. Like wood seems really hard, but actually it's just loads of space.
It is, to such a huge degree, everything that is mass is just empty space.
Madness. I just
Yeah.
don't think I understand reality anymore.
Yeah, like when you touch your desk, it's just kind of empty space pushing up against empty space.
Is that how water goes through things?
No.
No. Can things go around these electrons, or is the magnet pushing everything out of the electrons?
Do you mean sort of in between them and like through that
as
empty
they're
space?
whizzing about, can stuff go through them?
I think energy can, not other particles though.
Okay.
But that might be wrong.
And are they colourful?
No, colours don't exist at that size.
Where does colour come from?
Well, so colour is made from different wavelengths of light. So you can't have something, for example, that's red if that thing is smaller than the wavelength of red light.
I wish I hadn't asked that question. Didn't make me feel
let's
good.
move on. So, just like we had relative charge, with subatomic particles, we've got relative mass as well.
Yes.
So, a
That's
proton...
when you take your brother and sister and you go and ask God for forgiveness.
So, a proton weighs 1 relative mass.
A proton weighs 1?
And a neutron also weighs 1. They weigh the same.
Okay.
And
Proton,
electrons...
those are all the guys in the nucleus.
Yep.
These are the guys in the house. Okay.
Yep.
And an electron... I think they're going to be smaller. 0.5.
They are so small, we just completely ignore their mass.
What? So they're just a
Yes.
0?
Yep, they are a 0 when it comes to relative mass. So adding the protons and the neutrons in any given nucleus gives you the atomic mass of that nucleus. So that is the bigger number on in your periodic table.
Okay. So, going back to Molly Bednam, 95.94.
You'll notice that all of the atomic masses on your periodic table aren't round numbers. Could you hazard a guess why?
Because science sucks my big wet balls. Okay. Is it because they've got to add the skin of the nucleus to it?
No.
Is it because imperial?
It is because these are all averages. And as we've heard... So there are different isotopes for all of these things.
Isotope.
So that is the average atomic mass of any one of these elements.
Right. Well, that doesn't seem like a useful thing to know then. That's just a number that none of them weigh, isn't it?
Well, no, it absolutely does, because atoms, as we've discovered,
You're so
are...
defensive of science. Don't tell off my girlfriend science. I like to kiss her in the mornings. You idiot.
Stop trying to turn this into a comedy podcast.
Oh, I
It's
don't
not.
want it to be a science podcast. That's the problem.
God, a huge bird just flew by my window. Right, so the reason why that matters is because you never get one atom on its own.
Never ever. Lonely boys. Atoms are lonely boys.
No, I said you never get them on their own.
Yeah. They get lonely, so they hang around together.
Yeah, but then they wouldn't be lonely.
No, you can still be lonely if you hang out with someone. Tom and I have this argument all the time. He says that if we're in the same room, I'm not allowed to be lonely. And I said I can be lonely during a conversation. But that doesn't make any sense. Somebody that was alone is obviously not a lonely thing because they like their own company. Whereas atoms are clearly, they struggle when they're alone. So they're always with a friend. Atoms get lonely. So they hang out together.
The fucking mental hula hoops that you were expecting people to do to just jump on that fucking bandwagon.
Okay, Georgie. Atoms always come in pairs.
No, they always... Who said pairs?
Isn't that that's what I pictured? Atoms
Well,
always are never alone.
there are atoms always in pairs. Pairs are made out of atoms, just like anything else.
Hey! Atoms always are never alone. AAANA, that's how we'll remember that. It's the AAANA. Atoms are always never alone.
Yeah, but like I haven't really finished getting this point out. It's not that they can't be on their own. It's just that they're so small and there's so many of them that in practice they never are. Do you understand?
I'm liking an atom soup right now, aren't I?
Yeah.
Well, it's not that they're never alone, is it? They just make up everything, so everything is them.
Yeah, but like what I'm trying to say is that, say in a lab, if you were trying to measure the properties of beryllium, you would never have one beryllium atom to test. It would
Unless
always
you
be...
were firing it at somebody else's atom to do a nuclear bomb.
No. You
But
would
if you
always
went into
have...
space, could you put one atom on its own in space?
In theory, yes. In practice, no.
Why not?
Because we can't... It's very hard for us to do one atom. Atoms are very, very small.
Well, how did we split it then?
Chemical reactions and stuff.
I reckon we could get one on their own then.
Yeah, like I say,
Why don't we try and do that for the end of the series?
put one atom in space. Because we'd never know if we did it. Like it would
Thus
just...
proving my point that absolutely none of this fucking matters.
Yeah, but you can't just like suggest a thing we do and then go, yeah, that doesn't matter. It's like, okay, how about this? We go on holiday and spread some jam on the Taj Mahal, and then you're like, well, that's pointless. Why would we spread jam on the Taj Mahal? And then I go, yeah, see? What's the point of going on holiday?
But we'd know if we'd put jam on the Taj Mahal.
Not if we put it on the back.
Yeah, we would. I can walk round the back.
You've never seen the back of the Taj Mahal.
You've been caught out, buddy boy. Right, so atoms are always never alone.
AAANA. That's the episode title. Okay,
and
so
that's why we just measure the average. We just weigh it, and then we go, and that's 19 berylliums. That weight divided by 19 gives us... Oh, where's the notepad? Gives us 9.01.
Exactly. So students should be able to calculate the numbers of protons, neutrons, and electrons in an atom or ion, given its atomic number, mass number, and charge.
Brilliant.
So we're going to do this now, right now.
Oh dear. Okay.
So
I've made copious notes.
there is a sodium ion with a charge of +1.
Sodium ion has a charge of +1.
It has an atomic mass of 23.
It weighs 23.
and an atomic number of 11.
Atom number 11. Okay.
Tell me how many protons, how many neutrons, and how many electrons it's got.
Are you mad? I haven't got a clue. What?
Students should be able to calculate that.
Oh, hang on a minute. Okay. Wait. It's +1 is the charge.
Yep.
Electrons are out of the equation because they're the flyboys. They're too small.
No, I want to know the number of electrons as well, please.
I can't know that.
Yes, you can.
No, I can't. If it weighs 11, I think it must be 5 neutrons.
No, it doesn't weigh 11. Its atomic number is 11. Its atomic mass is 23.
What's the atomic number got to do with anything? What is the atomic number? What? What's the atomic number, please?
Work it out. Look at your periodic
I'm trying to
table.
work it out! I don't like to be told to work it out. That actually makes me really cross because you know I am working it out. You know I am.
You're asking me.
I can't remember what the atomic number means. Where's sodium? They should put these in alphabetical order. It's very hard to find them. I'm panicking now.
No, what order are they in, Laura?
Bigness.
What order are they in?
Size.
What defines the element?
Well, it's salt. I don't know.
No.
I hate being under pressure.
What is the difference between sodium and magnesium?
Sodium has one fewer whizzy boy.
Yes? Which one?
Uh,
Which one?
I'm thinking, don't shout at me. Electrons.
No, the other one.
I thought electrons were the whizzy boys.
The electrons are the whizzy boys. But remember the whizzy boys, differences in the whizzy boys, the electrons, that's what makes an ion.
Oh.
How did we change what element it was?
Radioactive energy.
But what particle? There's only 3, my love.
Protons?
Yeah. So the number of protons defines the element.
Oh, God.
Remember, magnesium has 1 more proton in its nucleus than sodium.
Yeah.
Magnesium's atomic number is 12. Sodium's atomic number
sodium's
is
got
11.
11 protons.
Yes.
Okay. It weighs 23. So it must have 12 neutrons.
Yes.
Okay. And then it's got a charge of 1 plus 1. So it must have 10 electrons.
Exactly. Yes.
God, that was stressful.
No, you worked it out. That was great.
Yeah, but I'm sweating so much. All because of a
So
thing
am
that
I.
isn't even salt yet.
Okay, we were going to do 2
And
more
that's
of those.
that's an ion.
Yes.
Why isn't it an atom?
Because it has a charge. There's not an equal number of
Okay,
protons.
yeah, because an
and
electron
electrons.
has disappeared off somewhere.
Exactly.
Okay, all right, give me another one.
Yeah. Okay. Helium is one of the noble gases, therefore it never forms an ion. So please tell me, if a helium atom had an atomic mass of 4, an atomic number of 2, how many of each type of particle it's got?
Okay, so I know that it's got 2 protons.
Exactly, yep.
So then it must mean it's got 2 neutrons. Because 2
Yep.
plus 2 equals 4.
And then it's a noble gas, so it could not be an ion.
So it must have 2 electrons.
Exactly.
The noble gases are the steady boys.
Yep, they're full. You know,
Yeah,
they've
yeah.
got full rings. They can't take on or lose any.
And they're really small.
Yes. I didn't think we talked about that. Nice. Well
Yeah,
done.
I nailed that after the initial panic.
So yeah, see, it's not that hard.
No, I'm a scientist now.
And that information has probably pushed out something else from the other side of your head. So lucky you.
Do I wipe front to back or back to front?
Okay, how do you feel about doing a bit of maths?
Well, I just smashed that math, so bring it on, I say.
Because students should be able to calculate the relative atomic mass of an element given the percentage abundance of its isotopes.
What?
Right, so have you got your pen ready?
Yes.
Okay.
This is the pen we got free from the jewellers when Tom bought my engagement ring.
God, you thought they'd given you a nicer pen.
Well, it wasn't that nice a ring.
Didn't his dad make your ring? Did his dad just give you a pen?
No, his dad made his wedding ring.
Okay. I thought it was just Jules being like, here you go, and here's a pen.
Julian does love to give us pens. It's his defining feature.
Right, so there are 3 different isotopes of oxygen. Oxygen 16, write that down.
Hang on. 3 different... Oxygen 16. That sounds like a cleaning. Are you a teenager with too many spots? Try oxygen 16.
Oxygen 17.
That is a one for somebody slightly older.
And oxygen 18.
Ooh, legally drinking. Is your skin dehydrated from going to Weatherspoons?
So oxygen 16 is 99.763% of oxygen.
Of all oxygen in the world.
Yep, in the universe that we've found. Oxygen 17 is 0.0375 of all oxygen.
God, I bet someone got a right spaffle when they discovered some of these oxygens.
And oxygen 18 is 0.1995%.
So 17 is the rarest one. 1995, that's the year you were born.
And I'm 18, so
Whoa.
mind blown.
Okay.
So now, from all of that information, you should be able to tell me the average atomic mass of oxygen.
Well, how could I possibly do that? What are you talking about?
Because you've got the percentages of the different masses.
No, I know how many these types of oxygens exist.
You've got the percentage of oxygen in the world that weighs 16, the percentage of it that weighs 17, the percentage of it that weighs 18. So you can work out the average mass.
But why? Who cares?
I knew you weren't going to like this episode.
Who cares? It's already so small that nobody gives a shit about it. And then you're telling me to weigh 0.0375% of the theoretical oxygen. Oh! Why? What help is this? Even if you fucking love oxygen, who cares?
Well, I mean, like, legitimately, for anything where you have to weigh chemicals, you need to know these things.
You can't weigh oxygen.
You can if there's enough of it.
There's loads.
Yes, and you can weigh it.
That is heavy.
Yeah, but you understand that oxygen can exist in other things.
So, all right, I'll do some sums and see what comes up here. All right, okay, so 16 times 99.763 equals 1,596.208. Then 17 times 0.0375 equals 0. This doesn't feel like it's going to be right. 6375. And then 18 times 0.1995 equals equals 3.591, then let's say add those together. 1596.208. That's probably too heavy. So let's wait, with percentages, don't you divide it by 100? Try that. Well, maybe if I've stumbled across this, I'm owed £1,000. I think the average weight of an oxygen is 16.004365.
I wasn't listening to everything you did. I got distracted, but
Welcome to my bloody world, mate.
yeah, that sounded right. Let us know in the comments if it was.
My first ever victory, and you weren't even listening. You were a garbage boy made of garbage food.
Hey, you've had many more victories than that. Don't put yourself down.
That was a massive one. You just gave me
Yeah.
barely any information, and I came out with the science answer.
It was brilliant.
Brilliant. Is that it now? Are we done now?
How are we doing for time?
It's been fucking ages. It's been
How long has
52
it?
minutes.
That's it. Oh god, I had like another page. Okay, well then, yeah.
Yeah. So you, listener, will hear a delightful little ditty now, but in our lives, a week will pass, and then we will be back for the quiz. We're back in the room. Laura is so tired and unenthusiastic, she'd utterly forgotten the episode happened. Ron, how do you feel about that?
You said.
Oh, it was all
we
the
don't have-
maths one. I remember.
You said, we don't have to do a quiz. We've done a quiz. But there's a
Yeah.
quiz every episode.
I know, but I thought we'd done a quiz but hadn't done an episode. But
If it makes you feel better, I haven't put any maths in the test because I
the
couldn't.
maths was the only bit I did well with.
Exactly, so no need to test you on
You
it.
are a stupid little bitch, and I hate you.
Hey now, don't slap me.
Oh, the Oscars just happened. Because this probably won't be going out for 6 months. We should do really topical references every episode that are then baffling by the time they go out.
Okay, do you have your notebook / a periodic table to hand?
I do. I've got my notebook.
I'd like you to
I'm
tell
going to call
me.
it Big Notey.
Big notey. I'd like you to tell me how many protons, neutrons, and electrons there are in a germanium ion that has a charge of 2+.
And what's awful is I remember so clearly that meaning something a week ago. I've got Mackie here to help me today. Geranium. It's got the number 32 on it. So that means it's got
Certainly means something.
32 electrons?
You can give me the answer for all three and then I'll give you the marks.
What was the question again?
Protons, neutrons, and electrons. The germanium ion has a charge of +2, and as germanium seems to have a few different isotopes. Let's say it's got an atomic mass of 73.
It has to have 32 electrons because that's the little number in the top right of the box. So then it's got so then it's got +2 charge. So it's got 2 more protons than electrons. So it's got 34 protons.
Yeah.
So then neutrons, what did you say, 73?
Yes, 73.
So 34 plus, What's 73 minus 34 on? Minus 34. So it's got 39 neutrons?
Christ, you really ate shit on that question. No,
Oh.
0 marks.
Oh, man! Oh, but I mathsed it!
No.
Oh, but so it has got 32 electrons, hasn't it?
No, it's got 32 protons.
Oh, fucking hell! Suck a dick! Oh! I think that the electrons should be what we call the whizzies out the outside ones.
Okay, well, but even then, there still wouldn't be 32.
Is it not? Is it... Oh, I thought that was how you knew. Oh. I thought that was what that number meant, was how many outside whizzes it had.
No, that's how many inside
Oh, that's
sitters.
how many DJs there are.
Yes, that is the number of Bob Marleys.
Shit. Okay. Right.
And then, yeah, so the 32 is how many Bob Marleys. So then you would subtract the 32 from the 73 to
So then there's
get...
41 electrons.
No, there's 41 sound engineers, the neutrons.
Oh, bastards. Okay.
And then, because it's got a charge of positive 2...
It's got
there
2
must-
electrons.
God, if you don't know, just let me finish the sentence.
2 protons. It's got 2 protons.
It's got 2 more protons than it's got electrons, because electrons have a...
43.
No, that was neutrons. It's got 30 electrons.
Okay, then. I haven't learned anything. I'm already sad today, and now I haven't learned anything.
Well, yeah, that was a honking fat 0.
For the listener at home, that pause there where Ron had no idea what to do in the face of an emotional response, that was my dad happening via his son. Just, well, that's how you feel. So, goodbye. Let's do some more facts.
The imperative facts say that, yes, you are shit, actually. Okay, Laura, can you tell me what an isotope is?
Probably not, Ron. It is the Springfield baseball team.
They were the isotopes, I'm afraid, so that's another 0. I would have accepted a member of the Springfield baseball
An
team.
isotope.
Yes.
Is that when there's different number of neutrons in the nucleus?
It absolutely is. Yes.
Yes!
So
Yes, I'm so happy.
yes, an isotope is a different mass caused by a different number of neutrons.
Yes.
Okay, 1 point.
Oh, thank God.
Okay. Next question. Staying on the theme of mass. Which is bigger, a proton or a neutron?
They're both relative to 1.
Yes, Laura. I thought I'd be tricksy. but
No,
yes.
I just was like, I don't know, I can't remember what you said they were roughly, but you said that we rounded everything up to 1 except electrons, which was 0 because they're too small.
Yes, so that.
And they are made of gold leaf, and then radiation goes through.
Yeah, we'll cut off the last bit, but yeah. So the relative mass of both protons and neutrons is 1, and that's not a rounding thing. They are just the same mass.
Well, we've made that up, but yeah, sure.
What do you mean we've made that up?
Well, we can't weigh them; they're too small.
Yes, we can weigh them.
With what? Tiny
Well-
mice scales?
No, it's just you get enough of them
Oh,
together.
imagine an ant standing on a scale looking at how much he weighs. It's a cute image. If you wanted to do a cartoon or anything. Does
You
my butt
draw
look
that
good
up.
and big in this? Of course it does. It's 2/3 of your body.
You could draw that up and have it as the album art
Yeah.
for this episode. What's funny about
Album ant art.
Jesus Christ!
I just want trying to distract you from the questions. If you think my jokes are bad, my science answers are so much worse.
What's quite funny about the format that we've chosen for this podcast is that listeners will get a sneak preview into the next episode. So when someone finishes chemistry 2, they're gonna hear this, and then they're gonna be like, "Oh God, physics 2 is gonna be a fucking mess."
Yeah.
Okay, well, I think you're on for another mark in the next question, because the next question is, what is relative charge?
How much magnetic energy these things have?
But specifically the concept
I
of...
hated the sound of you drinking then. That was horrible. What do you mean? What? Ugh, stop it, you grossy.
Oh, God. Specifically the concept of relative charge.
How much magnetic energy they have relative to each other?
Keep going.
How much magnetic energy they have relative to each other and all things? Relatively speaking?
Colder, further away. Oh, man, I thought that was an open fucking goal. You just basically talked about this for relative mass.
The relative charge. One! They're both one! Relatively.
What's both one?
Protons and electrons.
Keep going. Okay,
And
back on the right track.
Neutrons are 0.
Yes.
Yes?
And why do we do this?
Because we've got nothing else to do.
All right, 0 points.
No! No! Go away! No, because they kiss each other. They go to the party together. Don't they? No. They do. They get in, but they attract each other.
Yeah, no. It just makes it easier. So we say protons are positive 1, electrons are negative 1, and then when we're working out ions and shit, we can say, what charge it has in a round number.
Yeah, we're making it up as we go along. I already said that earlier.
Yeah, and it's minus points for that. You got 2 out of 6 on that quiz, Laura.
Fine. I would rather have 2 out of 6 and have my dignity.
So it was 3 for the first one, 1 point for protons, neutrons, and electrons, 1 for what an isotope is, 1 for what is bigger, proton and neutron, and then 1 for the relative charge for those following along at home.
Well, that was a mature end to a podcast, wasn't it?
Yes, I think it sums up your feeling about the quiz.
Thanks so much for listening, everybody. Now, I've got a couple of notes. I very much regret being disparaging about my engagement ring. It was I was joking, and I would just like to put that back into the ether that I love my engagement ring.
That's code for Tom might listen to this.
Tom actually loves this podcast, which is nice. But he does agree with you all the time and rolls his eyes a lot. But no, I love my engagement ring. And I think listening back to that, I thought that I was probably going to follow that up with a joke a bit more. And I never did. So it just sounds like I'm a spoilt bitch. But I love it. Anyway, I also wanted to know if you're listening, what's your go-to thing that's about a meter? Because I feel like Ron really laughed at me for saying a wheelbarrow, but I want to know what your go-to thing is.
We don't live in the fucking Archers. Like,
well, I have a garden. I don't have a wheelbarrow. There's too many steps in my garden. But anyway, what's your go-to thing that's about a meter? Also,
a meter is about a meter.
Yeah, but what do you just think about a meter ruler then?
Yeah, kind of. I just go like,
Oh,
that's
okay,
about a
just
litre.
nerd. Well, I think about a wheelbarrow. Anyway, when I was doing this maths bit about oxygen and Ron wasn't listening, was that the right answer? We need to know that as well, because Ron derelicted his duty. No, that's not it, is it? What's it?
Delegated.
Dereliction of duty?
Delegation.
No, it's... Well, whatever that word is, let us know that as well. Yo, you've got so much homework to do this week. Anyway, was that right?
I don't know. Did you
No,
say? Are you
because
talking to
you
me?
weren't listening.
No, sorry, I wasn't really listening then either.
You're a very bad man. No word on John Tickle Watch. We've had no response from Tickle's camp about coming on the podcast, which
No.
is sad.
That
but
is sad. And
expected.
what is he doing?
Yeah, what are you up to, John Tickle? And let us know if you scored better than 2 out of 6 on the quiz. Do you want to say anything, Ron?
Yeah. Did you get 3, 4, 5, or 6 on the quiz, or maybe 1?
Why are you such a sarcastic dickhead? You're so annoying.
I'm not. I lead the lessons. You lead the.
I did lead, but I can't do all of it because otherwise it's just a lecture, as you like to say. Anyway, see you all next week. Thank you very much for all the love and the love, I suppose, just again. And hey, do a cartoon of an ant on some scales. We want to see what that might look like. We'll see you next week when, oh God, it's physics next week.
Yeah.
Woof. Okay, we'll see you for that. But in the meantime, we're on all the social medias. We are at Lexx Education. Chat to us on Twitter, Instagram, sometimes TikTok, but increasingly less. YouTube, all the places. That's where we are. Facebook even. Facebook.
Remember
Hey.
Facebook?
Yeah, remember Facebook? That's still around. And, you know, we put stuff there in case your aunt's listening. So chat to us there and we will see you next week. Take care. Goodbye.
Class dismissed.